let's continue with more stuff related to measurements and errors and so on and so forth. A little bit of jargon associated with error involved in an experiment, error involved in measurement of a certain quantity. I mean, you could be measuring, let's say, the length of a wire using a scale, or you could be measuring, let's say, the diameter of a wire using a screw gauge. One way or the other, every time you're performing an experiment and you are coming up with a value of the measurement obtained, there is an error produced, right? That's called an experimental error. That's called an experimental error. And every time there is an error, you could assign causes to that error. There are essentially two kinds of errors that we can look at. One, systematic errors. Systematic errors are those where we have knowledge of the cause. Systematic errors are those where we have knowledge of the cause. And we have control over those errors. We can minimize those errors by controlling those causes. So a systematic error could be, let's say, for example, there could be a fault with the instrument. A systematic error could be also because, say, there is change in temperature, pressure, and humidity of the surroundings, right? We can do the entire experiment in a more controlled environment where these systematic errors could be reduced, minimized. So that's one kind of error. Systematic errors, like I said, and systematic errors are those where we have knowledge of the cause and we have greater control over these errors. The other kind of errors that we commonly encounter in experiment while producing measurements of a certain quantity, they are called random errors. There are also random errors, right? Now, when it's random errors, we have little or hardly any control over those causes, right? So in random errors, we don't have control over the cause. We don't have control over the cause. The cause is unknown. The cause is unknown. Or maybe even if the cause could be a factor where we can't control, that also could be looked upon as a random error. We can't do anything about that cause. And to minimize errors because of randomness, we carry out the experiment multiple times. We are measuring a quantity A. And we perform n trials of that experiment. N trials, the first one leading to an outcome A1, second one leading to an outcome A2, third one leading to an outcome A3, and then An. So the greater the value of n, the smaller would be the net random error produced, right? So, of course, it makes difference between performing the experiment fewer times and more number of times. More number of times means you'll minimize the errors, right? Now, what's an error? So we must define an error. When we are measuring a quantity A, we must know what is the meaning of error. Obviously, departure from true value. There is a measured value. When we are measuring a quantity, there is a measured value and there is a true value, right? The difference between the two is really the error, right? So essentially we say true value of a quantity A minus the measured value is the error. Hey, wait a minute. Measured value we know because that we have obtained by experiment. But what about the true value? After all, our aim is to obtain the true value or come closer to the true value, but we don't. So how do we know what the error is? We've just performed an experiment. And we have obtained a measured value. How far is it away from the true value can be known only if you, in a certain sense, estimate or guesstimate the true value in a model, right? So what we do is we say, all right, we carry out the experiment n times. And The n measurements obtained are A1, A2, A3, An are the n outcomes of that experiment, right? N measured values out of n trials of that experiment. And then we say, all right, if these are the n trials, these are the measured value in performing the experiment n times, we define what is called the mean of these, the average of these. The mean value of A is defined as the A1 plus A2 plus A3 plus An by n. The average of these AIs will be the mean value, and we say, all right, let's be practical. Let's call this mean value as the true value. Let's call the mean value as the true value. The greater the value of n, the closer we'll come to the true value. Am will come closer and closer to the true value, the larger the value of n, right? So true values essentially in our context is really the mean value, So now once we look upon this as the true value, then A1 will be different from Am, A2 will be different from Am, An will be different from Am. A1, A2, An are measured values, and they are different from Am in general. And this difference is referred to as an error, right? So the first trial, the measured value is A1 and the true value is taken to be Am. So what's the error produced? What's the absolute error produced? Absolute error is true value minus measured value. So true value minus measured value, that's the error produced in the first trial. What's the error produced in the second trial? True value minus the measured value. What's the error delta An produced in the nth trial? True value minus the measured value. So these are absolute errors. Some of them could be positive, some of them could be negative, some of them could be zero, which is all right. So we have now defined our absolute errors, right? Difference between true value and measured value. And true value is defined as an average of the measured values. Average of a certain number of measured values. Now, we define another quantity in this context, which is the mean absolute error. Mean absolute error. So, this is the absolute error, positive or negative, in the first trial. This is the absolute error in the second trial. This is the absolute error in the nth trial, right? And we take the magnitude of all of these. We take the magnitude of all of these errors, absolute errors, and then divide by the number of trials. Divide by the number of trials, and that quantity is called the mean absolute error. This quantity then is called the mean absolute error. The average of the magnitude of the absolute errors, the average of the magnitude of the absolute errors, right? Magnitude of absolute errors, take the average of that, that's called the mean absolute error. That's called the mean absolute error, right? So we've defined the mean absolute error in an experiment of n trials, and then we have what is called the relative or fractional error. Relative or fractional error. So it's like the mean absolute error, which is this, mean absolute error, which is this, divided by the true value or the mean value. Mean absolute error divided by the true value is called the relative or fractional error. Now, once we have the mean value, which is referred to as the true value, Am, and we have delta A mean. Delta A mean is the mean absolute error. Then we say, all right, the quantity that we are trying to measure, we write it as Am plus minus delta A mean. That means A is likely to lie between Am plus delta A mean and Am minus delta A mean. A is likely to lie between these two numbers, right? So the representation for A is written as Am plus minus delta A mean, where what is delta A mean? Is the mean absolute error, So one thing again, let me recap everything for you. So there is error in measurement, which is true value minus measured value. How does one obtain the true value? To obtain the true value, you have these n values out of n out of performing the experiment n times, take the average of that. That's the mean value, which is also taken to be as synonymous with the true value. And then we have absolute errors. Departure of these A1, A2, AN from AM are the absolute errors. So delta A1 would be true value minus measured value. Delta A2, true value minus measured value. So these are absolute errors. These are absolute errors, some of them positive, some of them negative, some of them 0. And then we take the magnitude of all of these delta AIs and divide by the number of times the experiment was performed. That will give me the mean absolute error. That will give me the mean absolute error. And mean absolute error divided by the mean value will give me relative or fractional error. And if you multiply by 100, that will give you the percentage fractional error. That will give you the percentage fractional error if you multiply by 100. And then finally the quantity A that we are trying to measure is written as AM plus minus delta A mean. That means A is likely to lie between AM plus delta A mean and AM minus delta A mean. So this is some basic jargon associated with error analysis, and you must take notice of all of this. Thank you so much. Bye-bye.